In this video, I want to show you a couple of problems where you're asked to determine the concentration or the minimum concentration to begin a precipitate when given an aqueous solution of one of the ions that are in the precipitate. So in this instance, the precipitate we're talking about is lead iodide, as shown in the chemical equation. The KSP is 9.8 times 10 to the minus 9. The solution that contains, we'll say, the common ion is lead nitrate. This is soluble. So remember, all nitrates are soluble. So aqueous 0.05 molar lead nitrate. So what we need to determine is what is that minimum concentration of the iodide ion to begin precipitation if there is 0.05 molar lead ion present. With this kind of a problem, it's not necessary to set up an ice table. So you could go right ahead and write the expression for the solubility product. Lead ion times the iodide ion. Remember to square it because there's a 2 here. Substituting what you know, of course, the KSP and the concentration of the lead, and then solve for the concentration of the iodide. And we could represent the concentration of the iodide as simply X. And then solve for that concentration and get 4.4 times 10 to the minus 4th molar. If the concentration is above this, you'll definitely precipitate lead iodide. Now I want to point out that this term here, the iodide term, I represent it here as X. So this is our unknown value that we're looking for, the concentration of iodide. You could put anything you want here to represent the unknown. You could put, if you want to set up an ice table or think of the stoichiometry, you could put a 2x here. If you do that, but be careful when you're reporting your answer, determining your answer. If you put a 2 here, let's say 2x, I'll just put it there for a moment. The answer you get for x is not your final answer. That is half the concentration of, in this case, the iodide, because the concentration of iodide is 2 times x. So I encourage you to plug in 2x here and then proceed and solve the problem. And when you get x, remember that x is not the concentration of the iodide. It's in fact half of it. So you have to multiply the x by 2 and you'll get this number here. But just to make the math a little bit easier, for these kinds of problems we could just plug in x. In this problem, the precipitate is magnesium hydroxide. And there's a bit of an application of the magnesium hydroxide here. In seawater, the concentration of magnesium is 1,350 milligrams per liter, or 1.350 grams per liter. So we're asked to determine the same thing as before. What's that concentration of hydroxide that will begin the precipitation of magnesium hydroxide? Well, the first thing we need to do is get that milligram per liter value into molarity, so we could use that value in the KSP expression. So 1.350 grams converted to molarity in 1 liter is 0.0555 molar magnesium ion. As we did before, we'll set up the solubility product expression where the KSP is 5.6 times 10 to the minus 12th, and our unknown in this case is hydroxide. And solving for x, which is the concentration of hydroxide, the value is 1.0 times 10 to the minus 5th. As I mentioned in the previous example, I encourage you to put a 2 there because that follows the stoichiometry of the equation. And remember that when you're solving for x, that x does not represent the concentration of the hydroxide. It represents, in fact, half the concentration of hydroxide. So when you get x, when you set up the problem this way, remember to multiply the x by 2 to get the concentration of hydroxide, and you'll come up with the same answer.